Welcome to Why Math Works. Today we are turning the real-world geopolitical problem of the Strait of Hormuz into a simple math puzzle. Imagine 100 ships trying to pass through one narrow doorway. Now imagine those ships are oil tankers, and that doorway is one of the most important sea routes on Earth, the Strait of Hormuz. This is not just geography, it is a mathematical bottleneck puzzle. A bottleneck happens when things arrive faster than they can pass through. Think of oil ships going through the Strait of Hormuz. If 10 ships arrive but only 6 pass, the line grows by 4 ships per hour. Next, we denote the arrival rate by lambda. We denote the capacity by mu. If lambda is greater than mu, the queue grows. The Strait of Hormuz acts like a narrow gate between the Persian Gulf and the open ocean. A huge amount of global energy trade depends on this passage. That makes the strait a perfect real-world example of a bottleneck. Do you know that about 20 million barrels per day pass through the strait in 2025, according to EIA? Here is our simplified puzzle. Suppose 10 ships arrive at the strait every hour. Under normal conditions, the strait can safely handle 10 ships per hour. So the system is balanced, no queue grows. But what happens if the capacity suddenly drops? Now suppose tension, bad weather, inspections or Iran blockade reduce the passage capacity by 50%. The arrival rate is still 10 ships per hour, but the strait can now handle only 5 ships per hour. That means the queue grows by 5 ships every hour. Let's calculate the backlog after 1 day. If the queue grows by 5 ships every hour, then after 24 hours, 120 ships are waiting. Here is the scary part. A bottleneck does not just delay one ship, it delays every ship behind it. If 120 ships are waiting, and the strait can clear only 5 extra ships per hour, it takes a long time to recover. For example, if normal arrivals return to 10 ships per hour, and the strait temporarily increases capacity to 15 ships per hour, then it clears 5 extra ships per hour. So even after conditions improve, it still takes another 24 hours to clear the queue. Now it is your turn. Suppose 12 ships arrive every hour, but only 8 ships can pass. Question: after 10 hours, how many ships are waiting? The answer is 40 ships. That is the bottleneck effect. So the Strait of Hormuz is not only a political or economic issue, it is also a math problem, a bottleneck, a queue, and a network under pressure. And sometimes the most powerful math puzzles are not in textbooks, they are on the map. That is all for today. Please write in the comments what video you'd like next. Maybe a new video about mathematical paradoxes, or one about non-traditional ways to solve math problems. Thanks for watching. If you enjoyed this video, please give it a like, subscribe, leave a comment, and share it. Thank you, and stay tuned for another interesting video coming soon.